Welcome. You're in Access Lunchtime. My name is Maria Barnes, and I'm the chapter president. Today we have Peter Cole, who is the director of Theme My Database, and he's going to be showing us some API statements and that work with 64-bit access. And talk about updating Access API calls. So please take it away, Peter.
Thanks, Maria. You will see from my company name of Theme My Database that my major interest is applying themes to Access databases. Today, we are going to be looking at what needs to be changed in VBA so that API calls will work with both 32-bit and 64-bit versions. Most samples on the web are for 32-bit and require updating for 64-bit. If you look at the Access web, or obviously Stephen Levens wrote things for 32-bit and they require updating for 64-bit. Since 64-bit Office was not available until Office 2010, the focus is on that version and later. We will look and see how it's possible to write code that would work with earlier versions. We'll do a recap of how we use Windows API calls in VBA. So in a module, we add a declare statement with details of the function and its parameters. Then somewhere else in the code, we make a call to that function declaration. If it's a function, we would have a variable equals API function with parameters. As in normal VBA functions, we don't have to return a value. If not, we leave the parenthesis out. We'll look at an example of the API function call getUsername. So it begins with the keyword declare, followed by function. There are also API subs. The name comes next, which is getUsername. This is the name that we will use within our VBA code, so it can be any valid name within VBA. Next comes the lib, which is the name of the DLL where the function is stored. Next comes the alias. Alias is a bit confusing, as the alias here is the real name within the DLL. This has to be in the same case as the DLL, so the uppercase parts in this name are absolutely essential. You'll see that there is a slight difference between the name that VBA is using and the alias name. There's an A added at the end of it. Next comes the parameters, which are exactly the same as in VBA. Finishes with a return type of long, and we'll look at the full function, so that collects everything together. So how do we make our changes? Well, we need the amazing PtrSafe. Or perhaps it's not so amazing. So we have to add PtrSafe to our declaration. So declare becomes declare PtrSafe. And all is well. Unfortunately, only in a very small number of cases. PtrSafe tells the compiler that the declare statement has been adjusted to use parameters and return values that are 64-bit compatible. It does nothing else. So where do we find the 64-bit details? The most commonly used API procedures in VBA are contained in Win32 API_PtrSafe, supplied by Microsoft. There's a link here. Clicking the link will open the Microsoft download page for the text file. And if we open that file, this is what we would see. This is a very long file. It has 1,550 declare statements, thousands of constants, and a few hundred type definitions. To make life easy, I've supplied a sample database. This will be able to be downloaded. It contains 3 sections: resources, which gives you a way of opening the text file, an examples section with 3 examples of functions, and some references which might be useful. Clicking Open Win32 API opens a copy of the text file in Notepad. This is on my second screen, so I'm going to drag it behind this sample database. If I look at an example of an API call, this sample here, which is going to be available for you to play around with. When I click here, it's pulling in a source module from an untouched database so that you can play around with it, delete it, and then just have another go. It's a very simple function which we probably wouldn't use, but it's a good example. So if we click here, we can see the code window.
This is Ben Satcherich. I joined late, so I didn't quite catch the whole thing here, but I think what you're trying to demonstrate in this presentation is how you can convert from 32-bit to 64-bit with your API calls. Is that right?
Yes, that's it.
Yeah, I recently had to do this on a project that I wrote maybe 20 years ago and have been enhancing all along, but never had a need to go to 64-bit. The process I thought was going to be a lot more difficult because I was always intimidated by those conditional compilation statements like Win64 and VBA 7, but I ended up not using any of those because we're so far ahead of needing to be backwards compatible that I didn't need to put that in.
You're very lucky if you don't have any users on pre-2010 then, Ben.
Right.
I still use conditional compilation because of that, but I think the challenge is usually trying to convert anything on Stephen Laban's site.
I agree, Colin.
If there's an obscure API, Stephen is bound to use it.
So we've got our function which was working fine in 32-bit, and now we've come to 64-bit. We've got this red code here. So if we try and compile that, we're going to see compile error. And it's telling us that something's got to be done to fix it for 64-bit. What we're going to need to do is find what this should look like in a 64-bit version. We're going to keep the original so we can see the difference. So we're going to comment this line, and then we're going to go across to the name of the function. We're going to copy it, and then we're going to go and look in the text file, and we're going to do a find, and we're going to paste in, and we're going to find that line. So we're now going to make a copy of that line and put it back in our database. So we're going to highlight the line, press the home key to move to the start, shift and end. Get to the end, copy it. I'd normally use Control and C to copy and jump back to our database code in a minute. If you want to go back to that text file, it's long. It's thousands of lines of, there are 1,500 declare statements. So we now go back to our code, and hopefully I haven't lost my pasting. I'm just going to split that line so we can see it all. As we can see, the thing which has changed is we've got this PtrSafe or PtrSafe at the beginning here, before the function. We've been lucky here. This is just one which actually works. Now, we can test this is working in this code by opening the immediate window. And then if we run this, the code which wasn't working is now working because we've added the PtrSafe in there. That's an amazing thing. We use PtrSafe. Unfortunately, that only does work for a few cases. As an alternative to using the text file, I have created an Access database with the contents of the text file in tables. This will be available for download. We will open it by clicking on Open API Viewer and then put it behind the sample database. You should open the API Viewer or the text file from the samples database before you work on any code. If there are errors in the code, then neither of the buttons will function. The next example is of clipboard functions. If we click here, then the VBA window will open. We see there's a lot of functions in here for operating with the clipboard. First one is Open Clipboard. We will comment it and then highlight the name. We're going to use our API Viewer. We get to the API Viewer by using Alt-Tab and selecting the appropriate window. We click in the Declares box and enter the name that we've just copied and hit Enter, and that's got the declaration for us ready on the clipboard. So we go back to our VBA code and paste with Control V. Here we see that we have a LongPtr type of variable for the HWND parameter.
When I was new to this, I was putting in long, long. And what's the difference between long, long and long pointer?
Some API procedures have parameters or return values that are pointers or handles. Those refer to memory addresses. In 32-bit Office, a memory address can be stored in a long variable, but in 64-bit Office, that has to be a long variable. To avoid having to change a lot of code, Microsoft introduced the long pointer pseudo-type. In 32-bit Office, it becomes a long value, and in 64-bit Office, it becomes a long value. Very clever. Using a LongPtr variable type will automatically adjust between 32 and 64-bit.
So long pointer is like the conditional version of 64-bit or 32-bit. It figures it out.
Yes. We will comment the next function and then copy the name of the function, set clipboard data, go to our API Viewer and paste in the name with Control V. The new declaration appears and we can go back to our code, move a line above and paste. We see that this function has a LongPtr parameter and returns a LongPtr. We will comment the next function and go copy the name and go to our API Viewer. Paste in the name, hit Enter, and that's got the declaration. Paste it in. Looking at the parameters, we can see they have a type of any. This means that the function can take a number of different types of variable. It's not the same as a variant. LSTRCPY is a function that is used to copy a string to a memory location, or a memory location which contains a string to be copied back to a string. The parameters can take either string values or a long pointer value. We would normally try and avoid using any because VBA can then not check when it's making a call to the function as to whether the values being input are valid. We will comment the remaining old declaration statements and then look at the LSTRCPY function in the text file from Microsoft. So we'll highlight the name, go to the text file and paste in the name, and we'll do a search, and we find it's found the LSTRCPYN function. If we look on the next line, we'll find the function that we actually want highlighted, and return to the VBA editor and paste. Split the line. We can see that both parameters here are string data type. This won't actually work for us, as in one call it's copying a string to a memory location, and that parameter would need to be a long pointer, and in the other call it's copying a long pointer to a string. I have amended the parameters in the API viewer so that they are both any. The declaration from the text file has an alias of LSTRCPYA.
Excuse me, may I interrupt with a comment, please?
Please do.
Philip talking, by the way, or everybody. Thank you. Good evening. I would like to clarify the situation with the alias. What you write behind the alias statement in quotes, that is actually the name of the function in the Windows DLL. And the function name you write after the function keyword is basically that what you would expect to be the alias in like SQL or similar languages. That is the name you use locally. So it's basically the other way around than normally than we are used to normally when writing SQL and using aliases. And so what is behind the alias is very important because that must match the name of the function inside the DLL.
Thank you, Philip. Very useful clarification. We have the remaining PtrSafe functions declared further down, which are commented, so we'll uncomment them. Now we will compile, and we find that there's an ambiguous declare. So that's where we'd left our text file version of LSTRCPY. We're going to comment that, compile again. We find another error on get clipboard data. We'll search for the function definition and we'll find that the return value is a LongPtr. If we come back to the code, clip memory is the variable it's attempting to assign, and we'll see that's a long, so we'll make that a LongPtr. We will also change LP clip memory. Compile again. We have another error. Retval needs to be a LongPtr, so we change the dim to LongPtr. Compile again, find another error, and we adjust for LongPtr, and another, and another. Compile again. No errors now, so we go our test sub and we run it, and we put in a bit of text to go onto the clipboard. Say OK, and we've got another error. It's errored on set clipboard data. So we'll go and have a look at the declare statement. and we look, and it said it couldn't find the alias. So we're going to amend that alias and take that A off. An uppercase A at the end of an alias name indicates that the function was written to work with ASCII characters. If it has an uppercase W, then it works with Unicode. In this case, the A was actually an error in the main text file and it should not be there. Removing the A, if we get another line, and we cancel because we're running, and the line removes the alias because the set clipboard data name is the same as the alias. So VBA automatically removes it. So we're going to compile again. No problems. So we're going to run our test function again. Put some more text in for the test. And we paste with Ctrl+V, and we've seen our texts. We're now going to look at the text size fit example. This is much more complex. This was written by Stephen Laban. We will recap type definitions. A type is a way of collecting data that can be logically grouped together. A rectangle is an easy example, as it defines the top left and bottom right corners of a rectangle. In code, you can define a variable with a dim, if we prefix it with UDT for user-defined type, rect as rect. You can refer to components of the type with a long var equals UDT rect.top. Within a width, you can refer to a long var equals dot top. Types are frequently used to pass data in and out of API functions. Types can contain elements that may be pointers, so for 64-bit compatibility we will need to use LongPtr. I'm going to scroll down to the first function, which is create font indirect. This time we're going to use the alias, as he has used a prefix on the name of API. So we're going to comment the line, and then we're going to go to the API viewer and clear the existing name and put in the alias name, hit enter, and then go back to our VBA code and paste in the line. You can see in here we have a user-defined type of log font as one of the parameters. If we scroll up, we'll see that the type is defined there. We're going to comment it. We're going to use the type from the type declarations. So this time we're going to go types, and we're going to enter log font. The elements don't show the type name and the end type. They will be added when the code is pasted after the commented section. We now move to the next function, create DC by num. Again, this is using the alias. So create DCA, highlight, copy, back into declares, paste in the alias, return to our VBA and paste. We'll split the line. Now we see in here that we have a type of dev mode. If we look in the original, it had LP init data as long. To check the declare statement, we can look at some Microsoft documentation. In the API viewer, we can click details from web, and it will store a search string for use on in a web cert. If we press OK, we go into a web browser and click Ctrl+V, paste in the search string, and we will see the declaration function, and we can see that dev mode is actually the last parameter. Close that. This is a special case where Stefan has found that we can actually use a long in this place rather than using dev mode. We're going to compile, and it's told us that there's an error, a type not defined. We're going to replace the line with dev mode in it with the line from the existing declaration. If we compile again, we'll find that the sub or function not declared. So that's because we have create DC by num in the original and create DC in the one that we have obtained from our API viewer. We update to create DC by num. We compile again and find an error with the type mismatch on the create DC by num. So we need to adjust HDC to LongPtr. Compile again. We see the error can't assign to array. This is trying to assign a string to the L-face name element of the myFont variable, which it's of type logfont. We find the type definition for logfont, and we scroll up and we can see our existing and our new version, and the LF face name is different. The existing was a string, and the one from the API viewer is a byte array. So we're going to comment the byte array and copy in the existing string definition.
Is that syntax times aside? Is that a constant there?
Yes, it's a constant. It's one of the many thousands which are used for API declarations.
Yeah, that makes the fixed length string. So Peter, you said about fixed length strings versus byte arrays, and what did you finally figure out? Are they actually the same?
Yes, a byte array is the same as a fixed length string, but they are manipulated in different ways within VBA. To assign a byte array to a string variable, we have to use a loop to add one character at a time up to the length of the string. We can see in our calling code that when we are going to pass in a string parameter, there is a CHR0 at the end of the string. It would be best to use the constant VB null char. The CHR0 represents the last character after the valid string that we're passing in. When handling strings, C uses the character 0 as a terminator. Anything after that point is of no relevance up to the length of the fixed string. We're now going to compile again. We have a type mismatch. We will look at the new font variable and we will change this to a LongPtr. Compile again. We have another type mismatch. This time we'll have a look at the definition of API select object. Do a find, and we'll find that there are three values that should be LongPtr, two parameters and the return value. We'll compile again to get to the error place, and then we'll look at the old font variable. That's the return value, so that should be a LongPtr. Compile again. We have a return value here, lngret. We'll change that to LongPtr. Compile once more. We have no compile errors. Just going to uncomment this line. we've got to click on the label on this form. We're going to open the test form and click on the label and then go back to our VB code, and we'll see that we've got 540 as the return value of the function. We will now look at compiler directives. There are very few functions that actually require this setting. I believe there's about 13 out of the 1550. So if you do need to use the specific Windows 64 versions, then you use the compiler directive #if win64, then use the 64-bit declaration, #else use the 32-bit declaration. To make code work with versions before 2010, you'll need to add a different type of compiler directive. That will be #if VBA 7 equals true, then the declarations will include PtrSafe, #else, then the declaration would not have the PtrSafe. You will also have to apply the VBA 7 condition in any types that use LongPtr, and also in your code you'll have to dim variable LongPtr as required for the API declarations that you're using. We will be seeing the quick method of applying all these updates, single click, but for those who wish to do it the slow way, you need to adjust all the declares using the API viewer or the WinPtrSafe text file. You need to adjust type definitions for elements which are different, usually LongPtr. Then you'll need to adjust the dims in the code calling the API functions. Update any len open parenthesis to len b open parenthesis when the len is used on a user-defined type. That is so that the correct length of the structure can be supplied to the API function.
We do have one question, Peter, and you can choose to answer this now or come back to it later. From Dwayne, he says, would it be feasible to create a wizard that would do all of the search and replace automatically with no copy and paste?
And that's just about what I'm going to be showing. It's not actually a wizard. It's a standalone database. It points at a database and will do all the conversions for you. So yes, but it has taken a considerable number of months to actually get to this state. In allsamples.accdb, we have the three modules that we've been looking at earlier. Get username, clipboard functions, and the text height or text size fit. And then we'll run this. So we can select any database. We've got that. I've got that one. It remembers what you did last in case you want to have another go, which we do. So I haven't put a slider on it to show how you're going because it just doesn't take very long. It's just processing through at the moment. Right. The flashing there is where it's generating some test forms for us. Processing is complete. That's a bit quicker than doing it by hand. So we'll now go back and have a look at this sample. We're going to take a look at what the updater has done. We'll look at the get username function. We'll see it's added the PtrSafe. There was nothing else which changed, so this one's okay. We'll have a look at the clipboard functions, and we can see Scrolling down, it's added the PtrSafe, but also where there's a requirement, it's changed long to LongPtr. We'll scroll down to where we're actually calling the functions. We will see that the variable names have been changed with some prefixes added. LPT indicates it's a long pointer, and LNG is a long, and STR is string. We'll notice here that we've got LNG retval and LPT retval. It's because there are multiple API functions called here. Some return a long and some return a long pointer. So we've separated the variables so there's a long pointer version and a long version. Looking at the text size fit, I've commented the old types. It's an option that you can turn it off or on. So if the old type is exactly the same, we could have it turn the commenting off. And if it's different, it will actually show you the new and the old. Right, now, as we have seen earlier, a number of the definitions within the text file, rather than using strings, they use byte arrays. So what comes out of the text file is actually says lface name 1 to a constant size and as byte. Now if you do that, you'll then find that the code and the calling code won't work because it's not a string anymore, it's a byte array. So what I've done is I've changed when the existing one has used a string, that means that the calling code further down is using a string. Therefore I've changed the definition back to the string value rather than using byte. Now if your calling code was actually using byte, it will want to remain as byte. So I'm checking whether things have changed, and if they have, then put it back to where it needs to be. LF face size is a constant value of 32. Yeah, that's face size. I think that's the length of the font string, which the name of a font. It can't be longer than 32 characters. If we scroll down to where log font was used, we find that my font has now been prefixed with UDT, which indicates that it's a user-defined type. This is very useful when we need to check for length. Some API calls require the length of a user-defined type entered as a parameter. You need to use the lenb function. Lenb gives you the size of the data type. So, right, so the code is all updated. So yes, a wizard could be created, but it does take a long time. And what I've done is I've set up some little test forms because when I'm running through the code, I have to be able to test things. I don't want to be writing new bits of code every time. So I've got it to generate a form and just some rubbish in there. We click our button, test complete. If we now do a clipboard get data, I'm going to appear it on my other screen. So it's now returned that data. So that's proving that that is working for us. So those forms are automatically generated by the translator. So every function or subroutine which actually calls a API function or sub will actually generate a form. So I can just click it and the text font, or this one's a bit more complicated because it's got a few variables in, but we're not actually using any of those at the moment. This is a Stefan Laban's thing, so it's a bit complicated. That tells you the height of the text string in this control up here. That was height or width, it's a Boolean. If we run that again, that will now say that is different. Okay, that's it.
Please, if you have a question, go ahead and either type it in the chat if you don't want to speak out loud, or unmute yourself and ask.
Peter, having spent 7 years struggling with 64-bit conversions and being moderately competent now, the obvious question is, how much of this are you going to give away, and how much of this is actually of your amazing utility is that for sale?
The amazing utility will be available for sale in February. Everything else which has been demonstrated is available. Not completely.
Have you decided a price?
What, can we canvass an opinion now as to what it's worth?
So one other question I have is, just probably for clarity here, in order to use this, you have to be using Access 2010 or above, correct?
Yes, because that is when 64-bit appeared, so you can't run it on anything earlier because the PtrSafe will not be recognized, because that's VBA 6.
So there would be no condition where you would want to use this and your version would be too old.
What you can do is you can put in conditional compile statements to avoid all the modern stuff and go back to the existing if you're going to run a pre-2010 version as well. But I understand that there are lots of people out there using older ones, but when are you going to want to use version and a new version?
I'm afraid there are occasions where you do, because you still get in a large institution the odd user who is on pre-2010. So as I said before, I still do conditional compilation.
Yeah, but that's reasonably rare
It's less rare than I would like.
I don't know, it should be from a support standpoint at this point, but yeah. So if you have a combined audience per se, and you need both pre-2010 and 64-bit in 2010 and newer, then that's when you have to use conditional compiles in addition to this technique.
Yes, because you've got to avoid all the code which is 64-bit. Can you persuade your users to use runtime, 2010 runtime, so they don't have to pay for a new access?
All right. Well, if that is it, I do want to announce that next month's meeting, which is December 28th, I believe. Yes, December 28th, again at 12 p.m. Central Time, which I think Peter and I just decided was, what, 6 GMT? Like that. Given the U.S.'s poor use of daylight savings some of the year and not others. Anyway, next month is going to be part 4, or the conclusion of general tips and tricks for the beginning developer. Crystal and I will be covering VBA. So we had this on our docket for part 3, and then we just got too involved in queries, I think it was. So this will conclude the general tips and tricks session. Thank you so much, Peter, for your presentation today. And we all, I think, look forward to your tool. It seems like a very useful and time-saving utility from my perspective.
Yes, indeed. Thank you, Peter. Excellent presentation.